Hi everyone, my name is Chen. I'm glad to have this chance to talk about my work. My topic today is AI-driven digital innovation towards Industry 4.0, which is to address my 3 years plan in digital engineering and my potential contributions. This slide shows my background. My presentation has 3 parts. First one, my research record. The second part, teaching experience. The third part is my potential contributions, including a research plan, teaching and learning, and management. First of all, I'd like to talk about my research record. My research interest has 3 parts. First of all, artificial intelligence. The second one, Industry 4.0, digital twins, digital manufacturing. And third one is robotics and autonomous system. I list a few my research achievements here. There are a few research papers, books, research grants, special issues as guest editor, special sessions as organizer or co-organizer, and a few other professional activities. And I also list 5 from my first author and papers for Ref 2021. And I have the experience for the Ref, so I think I can help and contribute to the next Ref. Grants. I list a few grants here as PI or co-I. I selected 2 research topics here to show my previous work related to digital engineering. So first one is computational intelligence aided design. We can consider it as an AI-driven tool. The second one is the hummingbird-like micro-air vehicle, short for MAV. It's a robotic system. Now the first one. So this is the conceptual framework for the CIAD. As you can see, it's a general conceptual framework for industry product design, which has been submitted to the ISO Artificial Intelligence Subcommittee. Now, with the conceptual framework at hand, we can and how we can build and to deliver the CID implementation. As we can see here, we have 8 blocks here. Block number 1 is the AI. Block number 5 is digital prototype, including CAD, CAE, and the virtual prototype. Then we move on to block 6. We have VR and AR to show the engineer and designer how we're gonna perform the designing and optimization, and move on to block number 7. With the virtual prototype at hand, we can build our physical prototype using the 3D printing technologies and some other rapid prototyping technologies. All above need to be supported by block number 8, which is high performance computing. Now, in a bigger picture, we can left-hand side is the red block. We can link our CIAD framework with block number 9, big data and cloud from field and applications, and the link to the right, block number 10, digital manufacturing, and on to the robotics, block number 11, and block number 12 go further steps, which can bring your conceptual thoughts directly to the industry product towards Industry 4.0. Now the second topic is hummingbird-like micro-air vehicle. For its small size, energy efficiency, and agility, it can be applied in rescue operation, monitoring, aerial photography, and the last one, autonomous population, is the one we are we are now working on. Now for the MAV, picture number 1, the number 2, the physical prototype for the wing. Picture number 3 is the virtual prototype for the body. Picture number 4 is the physical prototype for the body, and number 5 is the assembly model. There are a few wings model here. Now we're also working on the control design experiments test. And left hand side are the control design system. Right hand side, photo number 2 is the experimental test in a wind tunnel. Now the second part, teaching experience. I have been model leaders for more than 10 modules. I can teach at all level programs from year 1 to year 4, and also postgraduate programs. I list a few modules I've been taught here. My teaching style is kind of research enriched supervision, so my research can support my teaching and learning directly. So I can help me perform the effective teaching and learning. Now the third one, the potential contributions, research plan. So I think my research theme should focus on the AI-driven digital innovation towards Industry 4.0, which is in alignment with schools' existing research strengths in the AI and the digital, including the AI, machine learning, digital transformation, and IoT, VR, and immersive technologies. Now I think I have 2 areas under this theme. The first one is using CIAD as a tool for the product design. Here I just take the MAV for example. We're using the CIAD as a tool for digital prototyping for the robotics. Here MAV is robotics. So the first step is process. We have the model at hand, and then move on to step number 2, optimal design using the AI as a design tool, and move on to the third step, post process. When we have the virtual prototype at hand, and then we can build a physical prototype using 3D printing technologies, and then move on to the to build a assembly model and to perform the field test. Now the application is autonomous population. We will try to build an autonomous population system using the micro air vehicle. The brief idea is left hand side we have cameras on the top to obtain and capture the information from the ground, and the control center sends signals to the birds to perform the population task with the AI and human experience in the loop. Now we also have other robots here, so I just give 2. Here is a robotic fish. Another one is the unmanned surface vessel. So it's an unmanned surface vessel. Now the second area is AI-driven digital manufacturing, responding to the COVID-19. So Our AI tool is very powerful. It can provide support to digital manufacturing corresponding to COVID-19. We can currently we start from a smart device. So I list a few areas we're going to. In the future, we're planning for the research topics in the future. So we already started the first two, smart device and collaborative systems, and also preparing the proposal for assessing the impact of social distance measurement in an indoor space for UKRI COVID-19 call. And the national importance. So our research is very important. The AI, robotics and autonomous systems, digital manufacturing are all important. So the plan is for short term. I'm preparing for the first one, the Royal Society Exchange Program, UKRI, UKR COVID-19 call, and RSE Network Plus. We already submitted the proposal. Horizon 2021 call and the NERC. And for the midterm, and we're preparing for the EPRC network based on the previous one, the RSE one, network on robotics and AI for emergency and medical service. So we're preparing for the EPRC network and also aiming at the international joint research and the KTP project, and also looking at the gateway to the international opportunities for the long term. So I'm planning to establish a research center, provisionally center for the AI and digital innovation, and working on the proposals for the EPRC call and the NERC calls. In the same of manufacturing future, AI technologies, robotics, autonomous systems, and digital economy, and the digital technologies for the environmental science. Now, research version. My research is a step change in customization and the design capabilities for realizing AI-driven innovation beyond Industry 4.0 through industrial digital technologies, and with a focus on the application in robotic autonomous system. Contribution to teaching. My research can support me directly to the UG and PG program. I list a few here. So AI, autonomous and digital engineering, mechanical engineering, and digital technology solutions. And especially during the COVID-19 lockdown, I also developed a few online modules here. So besides the research and teaching, the third part of my potential contribution could be the management. I can contribute to the administrative activities, participate in professional activities, such as through the IET's professional network. And the last one, self-managing and mentoring the young staff. So CPD program. Now to summarize, research. My research is in the AI and digital engineering and teaching. My research can support me and contribute directly to the teaching and learning in this area. And the management in the research, teaching, and administrative activities. So this is the last page. I think my previous work can contribute and matches the university strategy for being the university of the fourth industrial revolution and delivering innovative, impactful excellency research. Thank you.